So hi, I'm Mohammad Sahil Ansari, a data science trainer and AI trainer. So today in this class, we learn the key concept that is a RAG and vector database. Okay. So today in this section, we have learned a vector database and the RAG. Okay. So what is RAG and database? So today agenda is we can learn just 1 second. What is vector database and how we can use a RAG and what is the RAG architectures we have used and what are the real analogies we can use and the simple RAG demo code with the help of vector database like FAISS or ChromaDB we can use. And the last we have summary and the Q&A session. Okay. So now let's start. So our today key, what is vector database? Okay. So I have just giving you some example like imagine you have a huge library and instead of searching books by exact title so or keyword, so vector database allow us to find the books by its context. For example, you have not know key what are the title of the book, but you know the concept key we know find the healthy recipes book. So when you write na healthy recipe, so automatically vector database search relevant content from the library. Okay. So in vector database, what is vector? So you can see there is a concept. You see there is a concept vector. Okay. So vector is nothing. It is a number representation of the text or any document. So for example, if you have any type of document PDF, you can just convert this text into numbers. And why we convert into numbers? Just because of fast search. Okay. And when it is convert into numbers, so the concept similarity matrix we can use to retrieve the data. Okay. So we use the retrieving the data from the matching dimensions. So this is a special type of word embedding. So we use a predefined word embedding concept. Also we can use a custom embedding system. Okay. So we have used this is a vector database. And what are the vector database concept? So you can see there. So you have a data. So data may be a PDF, MP4, MP3, whatever we have. And now we convert into an embedding system. And what algos we can use here? So we can use a context. So in this embeddings, we use multiple types. There is a custom embedding systems, or we can use LLM models embedding system. Okay. So what is LLM? That is a large language model, which is a pre-trained on a large data sets. Okay. So based on that data, it create a embedding, matlab numbers. After that, we can store. So we can store in number representations in our database. So these data are stored in a vector form. So that's why we called a vector database. Okay. And when we store now, so we again search the value. For example, we run the query and the query convert into the embedding and embedding query again search into the database, and that search things called a semantic search. Semantic means similarity, okay, which concept your context are similar, so we can use. Okay, so this is a basic overview of the vector database. Now we can move forward ki how it works and embedding. So first of all, we have used a loading. We just load the PDF or any file you have. Then we split the data into chunks because we have 100 words of 1000 words of PDF. So we can define a 200 in each chunks. So we can easily convert into embedding. Okay. So now we convert into embedding, then we can store. You can see we can just store our embedding format in the database like this. And when we have retrieved the information, we can use similarity search concept. Okay. So this is a vector database we can store. Now we can retrieve the data from this. Then how we can retrieve? So we use the capture the symmetric sentiments meaning enable task like semantic search. Semantic search means we have extract the keyword matches, question answering, we find the contextual relevant informations from the answers user can query. And personalized recommendations from the context we have passed on a vector database. Okay, so these are the some use case of the vector database. And now our real time we can use in every chatbot, we can use this database. Okay, so this is understanding key. If they have a vector, when we store in vector format, then how we can retrieve? So this is a query. Query means you have write in a text format, image format, or text. Now we can using the embedding models. Okay, embedding models means we have used LLMs or pre-trained model, or you can also simple, you can customize, then we can store it in vector database. Okay, when we store now, so the query goes through this part and search the similarity search with the help of one example. This is a cosine similarity. This is a mathematical terms, but it's do a difference between two words in a number format. Okay, so like hello and hi, what is the difference between the angles use? If the angle is less than 0 or approx 0, it means both the words are same. Okay, then relevant content it retrieves, and after that it pass into the combined prompt. If you are using LLM, we can use a vector database without LLM or with LLM. Okay, LLM helps to generate a custom data. Okay, but when you use without LLM, okay, so without LLM you use, this is the vector embeddings. Okay, and when we have response, so this is the full concept of RAG. Why we using a RAG? So RAG full form is retrieval augmented generations. Okay, retrieval augmented generation is a framework or a pipeline, we can say, that allow the LLM models to connect with the current or real time data. Okay, when you are using a real time data or custom data, okay, and combine three English words: retrieval. So what the meaning of retrieval? So the meaning of retrieval is to relevant retrieve informations from the large language model or in your custom data base. Okay. And then what is the meaning of generations? So generation is process of generating output based on the given input. If, for example, you have giving an input, ki what is AI, then you take the inputs, then augmented refers a relevant content on your database like vector database and search back and now generate it with the help of generations. Okay, and the third one is retrieval augmented, we have use here, and the generations we generate the text based on the LLM models. Okay, so the goal of RAG is simple: take informations parts into a LLM and based on that generate a output. Okay, so this is the basics overall concept of the RAG. So this is the overview, high level over architectures of RAG. So how it's run? Okay, for example, you run a query like what is AI? Then now we convert the text into a numbers. Okay, and these numbers use a vector store. So now it's stored in our database. Okay, and after that, or is search on a vector database. So after searching, the context means it also return our numbers. Okay, mind these numbers returns, and now these numbers pass into our LLM models like ChatGPT, Gemini, Lambda, Cold. We can pass, and based on that, the LLM return our answer. Okay, we can also directly connect our database with LLM to retrieve the informations from that part. So with the help of context, we can use it. Okay, so that's why RAG architecture important in chatbot. Okay, so this is the real use case. Key, you can just pass the query, embedding the context with the help of your relevant informations or your query based on your company requirement, company policy, whatever you have. Then based on that context, pass into LLM, and LLM generates the content. Okay, and after generating the content, you give back a output. So these are RAG architectures. Okay. So these are relevant argument applications. You can see key end user can pass the input. Then GNAIFs, you can use it. After that, the prompt pass to LLM and LLM, oh sorry, you can just pass our value to a company database, that is a vector database. And from vector database, it retrieve the relevant context. It retrieve the relevant context, what you want to search. Okay. After that, it pass into the LLM models, which is a pre-trained on the large data set like ChatGPT. And from the ChatGPT, it learn the context and answer according to the user. Okay. So you can pass the custom context, but flexible output. So these are RAG application. Okay. So now we can give a quick demo on the RAG. So I just RAG. So before you can start implementations of the RAG, you can just install a NumPy. Sorry, you can just install the Python. After installing the Python, you can need this type of libraries. So first one is tf.keras. It is a TensorFlow keras where we can implement all these things backend. FSS, this is a vector database we using to store our data. This is a sentence transformers. It is used to create a embedding, and after using a LangChain to apply these things in a one architecture. Okay, so we can apply directly with the help of LangChain. LangChain is an advanced concept on ChatGPT or chatbot system. So now we can import the libraries, and we have some documents like this. Okay, so first of all, we can just run it. After running, it's take a time if your library is already installed, and then create an embedding. Embedding is nothing, it converts our text. So this is our text. Okay, these text convert into these numbers. Okay, so this is our embedding system we have used. After that, converting it, we can build a FSS, means vector database. How we can import the fss.index.l2. We can add this document as an index. After that, we are using define a simple RAG architectures or functions. So there is a query. Query means the message the user can pass like what is AI. Then K is the most probability key. What are the most or highest probability data from the database? Then when we pass then we pass our query. The query is encoded. Encoded means we can just convert into an embedding system. Then we can search. What we can search the distance means what are the similarity between our query and the stored vector. So these are our store vector. These are our store vector. Okay, after that we can just write the query. This is the questions, and we have a write a RAG query applications, sorry, functions. And after implementations, you can see what are the response. So my question is what is AI? Okay, so when we write this question now, so it search most two relevant content from our database. Or what are the database? So these are our database content, which is already stored in vector embedding form. This. Okay, and this is our relevant documents. We can search key machine learning is a subset of AI and Python is a popular programming language. And this is our RAG response, and we have taken those things as a output based on our documents. So this is our basic demo on the RAG implementations. Okay, so that's all from my side. And if you taking some concept like why we use a RAG. So first of all, to take a efficient storage and relevant of high dimensions. And the second one is we can use to take a enhance our language models, and we can enhance our answer generations. Okay. and it also improve the accuracy and the relevance in the various applications, and it reduce the hallucinations from the LLM models. Okay. Sometimes LLM models have a facility to incorrect or misguiding based on the information, so we can stop these things. Okay. So, and RAG is particularly used for the working out with the custom data. Okay. So after RAG, we can use advanced LLM models and implement in real time applications like chatbot with the help of LangChain and LangGraph. Okay. So that's all. Thank you.